Science isn't just facts, it's stories. Nitrogen fills most of the air around you, yet you barely notice it. You inhale it constantly, you exhale it constantly, and it still acts like the quiet roommate of the atmosphere who never causes a scene. It makes up about 78% of the air, which is a hilarious amount of dominance for something that seems so unbothered and unreactive. Most of the time, it just floats in place, watching everything else happen. Nitrogen travels through the world as N2, a molecule with a triple bond so strong, it might as well be handcuffed and welded shut. Breaking that bond takes lightning storms, specialized bacteria, or industrial reactors willing to push physics around. That stubborn stability is why nitrogen gas is so harmless in the air. It refuses to react with anything at room temperature, which is great for breathing, but terrible for anything needing nitrogen in a useful form. Life needs nitrogen constantly, but not the version found in the air. Plants and animals require fixed nitrogen, which means chemically available forms like ammonia and nitrates. It is a strange setup. The atmosphere is loaded with nitrogen, but almost all living things are locked out of using it. It is like nature stocked the pantry and then lost the key. A tiny army of soil bacteria becomes the hero here. These organisms crack open the triple bond and convert N2 into ammonia, which plants can absorb and turn into the building blocks of life. Without these microscopic nitrogen hackers, ecosystems would collapse in days. Every protein, every blade of grass, every strand of DNA relies on the fixes these microbes perform. Humans eventually learned how to brute force the triple bond as well. Fritz Haber and Carl Bosch engineered a method to turn atmospheric nitrogen into ammonia using high heat and high pressure. Their system became the backbone of global fertilizer production. It feeds billions of people by providing a constant supply of usable nitrogen for crops. This invention also reshaped Earth's nitrogen cycle. Humans now fix more nitrogen each year through industry than nature does, through lightning and bacteria combined. Ammonia, the product of all this engineering, is both incredibly useful and demanding. It powers agriculture, refrigerates systems, supports chemical manufacturing, and shows up in surprising places. It is also corrosive and needs careful handling. The usefulness is huge, but so is the responsibility that comes with it. Inside your body, nitrogen builds your DNA, your proteins, and your amino acids. Everything from muscle fibers to neurotransmitters relies on nitrogen-based structures. But humans cannot pull nitrogen from the air. We get it entirely through food, handed down through the plant, and microbial worlds that unlocked it first. Nature runs a full nitrogen cycle to keep everything moving. Atmospheric nitrogen gets fixed in soil, absorbed by plants, eaten by animals, returned to the earth, and eventually converted back into N2. Lightning cracks apart N2 during storms and briefly cooks new fixed nitrogen into the landscape. It is one of nature's oldest chemical tricks. When farming adds too much nitrogen to the system, water sources get overloaded. Rivers and lakes fill with excess nutrients that fuel massive algae growth. These algae blooms drain oxygen from the water and create low oxygen zones, which disrupt marine life. It is a chain reaction driven by imbalance rather than malice. Nitrogen shows up all over the universe as well. Saturn's moon Titan has a thick nitrogen atmosphere that is even denser than Earth's. Nitrogen chemistry also appears on meteorites and icy moons, where it may help build the starting materials for complex organic molecules. Liquid nitrogen brings a completely different side of this element into the spotlight. At extremely low temperatures, it instantly freezes almost anything it touches. Flowers shatter, food turns brittle, materials behave in ways they never would at normal temperatures. Scientists and chefs both love it for different reasons. Its real value is in cryogenics, medical sample preservation, superconductivity experiments, and certain industrial processes that need deep cold. Liquid nitrogen also expands rapidly when it warms. A sealed container of it can produce enormous pressure, which is why any proper safety guide says never to trap liquid nitrogen in a closed environment. It is not trying to be dramatic. It is just physics doing what physics does when cold liquids boil into large amounts of gas. Nitrogen even contributes to food and drink beyond farming. Nitrogen gas makes packaged snacks last longer by pushing out reactive oxygen. Some coffees, beers, and specialty drinks use nitrogen to create a silky, creamy texture. The tiny nitrogen bubbles feel smoother than carbon dioxide bubbles. The famous creamy texture in certain stouts comes from dissolved nitrogen, turning a simple drink into a small physics performance. Future research is pushing nitrogen chemistry even further. Scientists are looking for cleaner, lower energy methods to produce ammonia without the enormous heat and pressure of Haber-Bosch. There is also work on engineered bacteria that can fix atmospheric nitrogen more efficiently, reducing the need for synthetic fertilizers. Other teams are studying nitrogen-based fuels and exploring whether sustainable versions could be used in aviation or energy storage. Nitrogen is not a flashy element, but it underpins almost everything on Earth. It runs through biology, agriculture, weather, chemistry, and even planetary science. Its quiet personality in the atmosphere is completely opposite its importance in your cells. It just goes about its job without making a scene. Every breath you take is mostly nitrogen. Every protein in your body owes its existence to nitrogen. Every farm on Earth depends on nitrogen chemistry in one form or another. Even the coldest cryogenic labs are powered by nitrogen's extreme behavior. It spans a range from totally calm to unbelievably energetic, depending on how humans interact with it. It may not sparkle or roar or glow, but nitrogen is one of the foundational players in both life and technology. If carbon is the charismatic element everyone talks about, nitrogen is the one making sure the entire system runs smoothly behind the scenes. The next time you look at the sky, remember that almost all of it is nitrogen silently floating overhead. You are living in a world built on top of a massive ocean of invisible, essential gas. Nitrogen shapes the air, the soil, the oceans, and your biology without asking for applause. It is one of the humblest and most powerful elements in the periodic table.